Let's take a look at some code that demonstrates these concepts. So here's a test instance member. This creates two separate instances of a custom customer class. And it uses a constructor that passes in a customer ID. As you can see, the customer ID value is a string, short string. And then it sets the customer name property of cust A, the first of the two instances of the object, to Maria Anders. All right, and then the remaining code here calls the toString method of cust A and cust B so that we can see what each of those are. Now, in this example, because cust A and cust B refer to distinct instances of the customer class, there's two objects in memory, two customer objects in memory once these statements have executed. Modifying the customer name property in one instance doesn't affect the customer name property in the other. These are instance methods, and so in this case property, and so the customer name property of one doesn't contain the same information as the customer name property of the other object. So I'll go ahead and press F5 to run this code. And I'll hit E to test the instance member. All right, so as you can see, cust A has a customer name of Maria Anders, but customer B has an empty customer name because we didn't set the value of that property. So again, this is just demonstrating that customer name of this one is different from customer name of that one because these are instance members, in this case properties. And close down the application. Now you do have the option of creating members that are shared across all instances of the class. And you do that with the static keyword. So when you use that keyword, you can indicate that you want a property, field, or method associated with all instances of the class, not just a specific instance. For properties and fields, this means that there will be just a single copy of that data in memory, and all instances of the class use the same value. If you change the value of the property or field, all instances of the class are going to see that new value. And for methods, that means that you don't create an instance of the class to call the method. The class itself, rather than an instance of the class, provides that static method. Okay, so consider the system.string class. This is a class of the .NET Framework. The class provides a number of instance methods, like index of, and a number of static members, like the concat method. Index of finds the location of a particular string within the string, and concat concatenates different strings together. So in order to call the index of method, you have to create an instance of the string class. But in order to call the concat method, you don't. All right, so we have this method here that demonstrates that. So the test instance and static methods first declares a value, a string variable called value, and puts in A, B, C, D, E. And then I want to find the location of B in that string. So because index of is an instance method, I need an instance of the object in memory. And I have it right here. I declared, and this is the statement that put that variable, that object, that string object into memory. And so, because I have an instance of that object, I can call index of, and then pos, or position, whatever, is going to contain the position of that letter, or -1 if it doesn't find it. And then I can write out that value. On the other hand, concat is a static method. So instead of using something like value, or I can even use a literal string in the case of index of, I didn't need to create a value variable if I didn't want to. Here, I'm actually using the string object. So if I hover over value, you can see it's a local variable of type string. But if I hover over this, you can see that it's actually the system.string class. And because the concat method is declared as a static method, I can call it directly on the string object, actually the string class really, and then pass in the strings that I want to concatenate together. So when I run this code, I'll hit F, and you can see that the position of B is 1. It's a zero-based location. And then here's concat these together. Concat space these space together. Okay, so that's how that works. But in order to demonstrate the behavior of static properties and explore them a little bit more, let's take a look at the customer object, customer class. So this class contains a property called default country. And this is a static property because I'm using the static keyword as part of the declaration. Now, because this is a static method, I have a backing field, or let me restate that. Properties generally have backing fields. So this is where the data associated with a property is stored. You don't have to have a backing field. There's various ways of doing that. I'm not going to talk about that now. But in this particular case, when I write to the default country property, the code is going to assign that value to this underscore default country variable. When I read it, it's going to return the value of that variable. Now, that raises kind of an issue. Because this is a static property, I don't need an instance of this class in memory in order to access this property. But if I have a backing field, I need some place to store that. If I don't have a static backing field, which is shared across all of the objects of this class in memory, then I wouldn't have any place to store this. So any resources within the class that I access from a static method or a static property have to themselves be static. Okay, so don't worry about that too much. Just keep in mind the general principle that static members, any resources within the class they reference, need to themselves be static members. Okay, so that's the definition within this customer class. So if I go back over here to program, I have this test static property. So what this does is it once again news up an instance of the customer object and passes in a customer ID. And then it's going to read the value of the country property and display it on the console. All right, so that code is pretty straightforward. It's what we've been doing all along. But now what I'm going to do is execute this statement that changes the default country. So if I go back over here to the class, the default country is initially USA. But now this line of code right here is going to change the value of a static property. That's going to change it for all instances of the customer object that I have in memory. It's a static member, and so I need to execute it on the class itself, not on an instance of the class. All right, so this is stored for all objects in memory. Default country after the statement executes is going to be the UK. I new up another customer object, and it's going to set the country to the UK because it's the default country. I can change it in my code. I can change the value of the country property, but if I don't do that, the country value is going to be UK. All right, and so then this code is going to display the value of the country property for both of those objects in memory. So I'll go ahead and run the code. I'll hit G for test static property. All right, so as you can see, the value of country is initially USA. So I created an object here. I didn't change the default country, so country is set to USA because that's the default. And I display that, and that's that first line there. Then I change the default country. So this is going to apply to all new instances of the customer object in memory. I create a new object, and that is set to the UK. Then I display, once again, the value of cust A country. It's still USA. I haven't changed the country of this object. But then cust B is UK because when I created this object, default country was set to UK. Okay, so that's how instance and static members behave. So it's pretty easy to summarize the behavior of instance versus static members. Instance members apply to a single instance of a class. And static members apply to all instances of the class. And you access instance members using a variable that refers to a specific instance, a variable that has a reference to an instance of that object in memory. But you access static members using the name of the class. And that's what I did here when I used customer in order to access the static method or property default country. Now it's important to note that static members and instance members live in separate but parallel universes. This kind of makes sense once you internalize the fact that static members exist only once in memory and apply to all instances of the class. Instance members, on the other hand, can exist multiple times in memory, one instance for each instance of the class. All right, so consider some specific issues. The first is that main is static. So this is the application startup procedure, always called main, and it's always declared using the static keyword. Now that you've examined the meaning of that keyword, this should make sense. The .NET runtime needs to be able to call the main procedure without requiring an instance of the class. There can only be one running main procedure per application. Therefore, the main procedure is always static. Second issue is that main can only interact with static members. Because the main method is static, it can only interact directly with other variables and methods that are also static. And I kind of got into that when I explained about default country needing to use a static backing field. Now, of course, code that main calls can create an instance of a class. It can also create an instance of the class containing main. But unless it does, it won't be able to call a method or work with a variable or property that isn't static. And then finally, instance members can interact with static members. So code running within an instance member can always access properties, fields, and methods that are static, no matter what class they're in. Okay, so getting used to working with static members can be a bit tricky until you really try it a few times. So think about it this way. Static members have it easy. They're always available without needing an instance of the class they're hosted by. In order to use other members, that is, instance members, you have to create an instance of the class. And once you have this fact internalized, you'll find working with static and instance members not to be a challenge at all. Okay, so let's switch gears a little bit. Still going to talk about static stuff, but there's this thing called a using static directive. Now, in each new version of C#, Microsoft often adds features that make using common coding patterns easier, resulting in simpler, cleaner code that you have to write to implement to the same sort of feature. One example of that kind of an addition to the language is the using static directive. This lets you import all of the accessible static members of a type. This makes all of those members available without qualification in the code file where you include the statement. Now, regular using directives import namespaces, and we've seen a number of those in the course so far. But using static directives import the static members of classes. Both save you keystrokes when writing code, normally with no impact on the readability of your code whatsoever. All right, so say that you have a code file that makes heavy use of the system.console and system.math objects. In order to save typing, you can include these two using static statements within your code file. All right, so then if I come down here to using static, I'll select that and hit F12 to go to the definition. Here shows the difference between whether or not you use that using static. Without the using static directive, I would have to write the code like this in order to get the square root of the operand. So I have to explicitly say math.square root because I have to provide the name of the class that implements that method. And similarly, I have to use the console object in order to call this static method of the console object. WriteLine is the static method. Okay, so WriteLine and square root are both static methods. And again, without using static, I have to write my code this way. But because I included those two using static statements, I don't need to include the console object and I don't need to include the math object there because I've imported these static methods, in fact, all of the static methods of the console and math classes. And in fact, if WriteLine or square root were not static methods, if I tried to write it this way, I would get an error, a compiler error, so long before the code even runs, because the compiler wouldn't be able to figure out what this method is and what that method is. I haven't provided it enough information in order to tell it where to find that. Unless within this class I happen to have defined those methods of those two names. I don't in this particular file, and so that would cause a compiler error without those using static methods. So in essence, using static directives take the use of the using keyword a whole step further. It really is a different kind of directive. And it lets you reduce the code that you have to write even further. This is a particularly great feature when you have a set of functions from a single or a small number of classes that you use extensively within a code file. And like other using directives, using static directives affect only the code file in which you include them. So by including them here within program.cs doesn't import those static methods to any other code file. And as with so many such productivity improvements, these sort of improvements that Microsoft adds to C# that help or let us write less code, using static is just syntactical sugar. The compiler translates the abbreviated references into fully qualified references. And you can see that if you look at the IL code. There's no magic going on here. Okay, but there is a potential problem with any using directive. And that's by dropping the need to use fully qualified object and method names, you increase the chances of name collisions, leading to ambiguity and potentially compiler errors. Okay, so say for example, if I go back up to the top of the file, say that I import the static members of the directory, file, and path objects. And these are all part of the system.io namespace. Then if I go back down to using static, this causes a bit of a problem. So I next have a line of code here that declares an array of strings called files, and it's going to use this getFile method. And this is a getFile method of the directory object. No problem here. Directory is unambiguous. There's no other object that has a getFiles method, so I can do that. Because I included the using static system.io.directory, I don't need to include the directory name there. And I can pass in the folder name, the mask for the files that I want, and whether or not to search just that top level folder or all of the folders. And in order to search all the folders, I include the system.io.searchOption.all directories. And then getFiles will return an array of all of the files that it finds at that location. Okay, but here's the problem. I'm going to comment out this statement here and uncomment this one. And I move off of it, and notice that we immediately get a red squiggly. Never a good sign. So if I hover over this, it says that the call is ambiguous between the following methods or properties: directory.exists and file.exists. So what's going on here is that because I included using static directives for both system.io.file and system.io.directory, it can't determine which version of the exists method I want to use. Because again, both directory and file have an exists method. Exists for directory tells you if the directory or the folder exists. Exists for file tells you if a specific file exists. Now clearly here, I want file exists, but the compiler doesn't know that. Okay, so I'm going to undo that change. And now, in order to solve that, I need to tell it, even though I've included a using static for system.io.file, I need to tell it that in this case right here, I unambiguously want the exist that is on the file object. Okay, so here I pass in a file name. It's in this case, the first element of the array, and then it returns true or false if that particular file exists. And of course it's going to exist because I just read those files. Although between here and that statement, some other process could have deleted that file. So this may actually return false. Okay, and then once I do that, I can then successfully execute this code, the body of the if statement. Okay, and then this sort of problem also would occur if I were to define an exists method within this class. So even if I included only system.io.file, not directory, but I had an exists method in this class, I would get the same errors we saw with this statement because once again the compiler wouldn't be able to tell which exist method that I wanted. Okay, now a related problem can arise if, say for example, I include only the using static system.io.directory. Just include that directive, but not the using static system.io.file. Because if I were to use the exists method without qualification to check for the existence of a file, the compiler would complain because it would be trying to use the directory object's exists method, which takes a folder name, not a file name. But there too, you can solve the problem in the same way by explicitly specifying the name of the class for the exists method that you actually want to use. Now, it's important to understand that the using static directive only imports the static members of a class that are accessible from the code in the code file. This includes any nested types, but not inherited members. And you can import from any name type with a using static directive, including Visual Basic modules. So if you have different modules that are written in C# and Visual Basic, this works across. So this means that you have to use the static keyword on any methods that you want to import. And that usually means the public accessor on the method as well. So to drive this point home, consider another class. It's called static stuff. This defines two methods. One's an instance method and the other is a static method. Okay, so this is the instance method. I know that because it's not defined with the static keyword here. And it's going to use this random number class in order to generate a random number. And then here's the static member that is also going to use that random object, and that's why this object or this variable itself has to be declared static because it's used from a static method. So this one is just going to return an unbounded random number, and this is going to return a random number between 0 and 100. Okay, so I'll come back over to my program.cs, and I have this code here. So I'm going to uncomment this code. And as you can see, I have a compiler error here because I'm attempting to reference this getRandomNumber. And if I come back over here to static stuff, this is an instance member. And an instance member is not imported with a using static statement. So if I come back over to the top of the file, you see that I have using static classes.static stuff. This is going to import the static members, but not the instance members. So once again, because this is not automatically imported, it's not a static member, it doesn't know, the compiler doesn't know where to find this method. And so if I hover over it, it says the name getRandomNum does not exist in the current context. Okay, so that's not going to work. I would need to create an instance of that static stuff class, and then I would be able to reference that method using that instance variable. But notice that this one's not a problem. That using static directive imported this static method. The compiler knows exactly which method I'm attempting to call, and this line of code will compile and execute with no problem whatsoever. All right, and then the using static directive also works for enums. So I have this statement here, but I'll come back over up to the top of the file. And as you can see, I have a using static for system.dayofweek, which is an enum. So you can see the definition of that. And then if I once again go to using static, I don't need to preface any of these enum names with that day of week object. Okay, so I can just use Monday, Thursday, Monday and Thursday in my code directly. All right, I'll run this code and hit H for using static, and you can see the results. So I'm using a static method there to calculate the square root. Customer.cs file exists. I told the compiler which exists method that I wanted to use. And then I generate a random number, and then I do a little bit of enum math there. And I don't need to explicitly reference or tell the compiler what enum these are part of, because I imported those static objects as part of using static directive.